Hi there! Today we're working on one-step equations translations and solving one-step equations on the next page. So I'm on page 20 in your binder and I'm on notes 5-2 one-step equations and translations. So if we look at this, we're going to practice translating one-step equations. So when translating statements into expressions and equations, the order of the numbers and the letters is important. And just like whenever we were translating equations in our order of operations unit, we're going to have different keywords that we need to look out for. So if we go through these words, some are going to mean add, some are going to mean subtract, multiply, divide, and our flip words, and some equal words. So pause the video here, see if you can sort the words into their correct categories. Alright, so here are the answers. Take a moment to check over your work to make sure everything is in the right area. Watch out for squared. Remember, squared is anything to the second power. Quotient goes in divide. That's our DQ word, divide quotient. Ratio also goes there because a way of writing a ratio is as a fraction. So a ratio is actually a fraction, which means division. Your flip words are still the same, the than and the from. Always watch out for those. And then the new category that was added were the equal words. Were, are, will be, is, was. Those are all words that say something is equal to. If we look at the bottom of that page, we're going to do the translation just like we did with the order of operations. So the difference means subtract of 6 and r is an equal word, 25. So if I reorder this, 6 minus r equals 25 would be the answer for that one. For number 2, after dividing the money 5 ways, and we don't know what the money is, so I'm going to use M. Each person got, which is an equal word, $67. So you could write it M divided by 5, or you can put a division sign, either way works, equals 67. So go ahead, pause the video here. I want you to try 3, 4, 5, 6, and 7 on your own. When you're ready, unpause the video to check your work. Alright, let's check our work really quick. So we have 7 less than is a flip word. A number, which we don't know, could be a letter, is 15. So whenever we rewrite this with our than, we're going to have n minus 7 equals 15. For number 4, the total, which is an add word, of 5 and c will be negative 5. So we have 5 plus c equals negative 5. 7 less than, watch that flip word, m, was negative 10. So I'm going to rewrite it, m minus 7, I have that flip word, equals negative 10. The ratio of a number, which we don't know, and 10 is 18. So we have n over 10 equals 18. You could also have a division symbol. 14 less than 20 will be j. Remember, watch that flip word. So 20 minus 14 equals j. Alright, if we look at the next page, we're talking about vocabulary, and it got kind of cut off a little bit, but we're on page 21 in your binder. So, a variable is a letter that is used to represent one or more numbers in an expression, equation, or inequality. So it's the thing that we don't know. So it could be an x, it could be a y, it could be an m, it could be a q, it could be a z, it could be any of those letters. A term is a real number, a variable, or a combination of real numbers and variables. So I like to refer to the terms as the chunks of the problem. So if we look in an example, let's say we have 3x plus 4, or plus 5, sure, equals 7. This right here, this 3x, is a chunk of the problem. That's a term. This positive 5 here is a term, and this positive 7 here is a term. The sign is always going to go with the number it's in front of whenever you're looking at terms. The coefficient, the CO here, just like when we were doing properties, the co and commutative meant change order. When we're working with the vocabulary, a coefficient is a coworker to the variable. So the number that is multiplied by the variable. So if we have an example, 3x plus 5 equals 7, we'll just use that one again. The coworker here, or the coefficient, is actually going to be the 3 in this example, because the 3 is working with the x. And the constant is a term that does not contain a variable. I always remember the constant. It's constantly alone. It's a sad number. It's all by itself. It doesn't have a variable to work with. So if we look at our example that we've been using, our constants are going to be this negative 5 here and this positive 7. Those are constants. They're all by themselves. So if we look at this example down below, let's label all the parts. So the first thing, I'm going to start with the variable. The y is the variable. Okay, I'm going to skip term for right now. The coefficient is the coworker to the variable. So if there's a variable, there's always going to be a coefficient. Even if the variable is just x, it's going to have a coefficient of 1. So if we look at the coefficient here, it's going to be negative 3. That is the coworker. Then we need to look at the constants. The constants are the numbers that are all by themselves. So it's a positive 7. Remember to take the sign always. So this is a constant. And so is the positive 10. Remember to take the sign with it, and that's also a constant. Then I skipped terms. Let's go back to the terms. So we're looking at the chunks of the problem. This here, this negative 3y, is all a term. Same thing with the positive 7. That is a term. Same thing with the positive 10. That is also a term. So there are 3 terms in this problem. So your job is to try the one down below. Label all the pieces of the problem using the word bank above. Pause the video here and unpause the video when you're ready. Okay, there is your answer for how to label an expression or equation.